It is easy to cherry-pick a retrieval demo and hard to compare models fairly. I'll use PyTerrier and BEIR to benchmark BM25, SPLADE, and ColBERT in Python. This is the workflow you'll know how to run when we're done, which compares 3 retrievers head-to-head and reports the winner using a ranking score at 10. I'm Professor Pi, teaching search and IR with simple Python. Search teams face a common problem. You can show a single query where your fancy new model shines and call it a win. But production needs reproducible, fair comparisons across many queries and clear metrics that reflect user intent. BEIR-style benchmarking gives you that repeatable setup. And PyTerrier is a pragmatic Python toolkit that wires retrieval, re-ranking, and evaluation without reinventing indexing or metrics. Success looks like a single table saying which system orders relevant documents best across a set of real queries. At its core, BEIR-style benchmarking asks a simple question. Given the same queries and relevance labels, which pipeline ranks relevant documents higher on average? Think of queries as questions, documents as answer cards, and creels as a teacher marking which cards contain the right answers. We measure performance with a ranking metric so you can pick the best system for your use case. We will build a tiny, reproducible example that mirrors a full BEIR comparison but fits in a notebook. You will see a minimal index, run BM25, then plug in 2 learned re-rankers, and finally compare all 3 on the same queries and crels. That way, the code reads like the real workflow, and you can scale it later without reworking the logic. Now we'll create a tiny index and issue a simple BM25 query. This snippet builds a tiny Terrier index with PyTerrier and retrieves a top document using BM25. It starts PyTerrier with init to load the backend, then creates a small list of dictionaries named docs containing doc identifiers and text. The iterdict indexer writes these into a local index folder and returns an index reference. The batch retrieve object, BM25, wraps Terrier's BM25 search over that index. We issue a simple query string to search, receive a ranked data frame, and take the first row's docno as the top result. Increasing collection size or query length typically changes which document surfaces first. The printed ID confirms BM25 is wired and ranking documents. Next, we will run a compact BEIR-style evaluation for BM25. This example runs a compact BEIR-style evaluation of BM25 with PyTerrier's experiment. The data frame queries holds 2 toy kids and their query texts, while crels encodes graded relevance labels for specific kid-docno pairs. The experiment function executes BM25 across the queries, joins results with querels, and computes the requested nDCG cut3 metric, where nDCG cut3 measures ranking quality focusing on the top 3 positions. We then read the metric cell into S and format it for display. Raising the cutoff to nDCG cut 10 makes the score more sensitive to deeper ranks, but increases required candidate coverage. The printed nDCG tells you how well BM25 orders relevant documents near the top on this toy set. Now we'll add a learned sparse re-ranker and plug it into the pipeline. This code adds a SPLADE re-ranker to BM25 using PyTerrier and PyTerrier SPLADE. The SPLADE factory loads the Naver SPLADE co-condenser ensemble distal model on CPU and exposes TextScorer, a transformer that scores each document against the query using sparse learned interactions. The pipeline first limits BM25 to its top 3 candidates with the % operator. Then getText injects raw document text from the index, so SPLADE can score. And finally, SPLADE replaces scores. Experiment evaluates the re-ranked results with nDCG cut 3, increasing the candidate pool. For example, changing the percent to cover more documents often improves re-rank quality at extra latency. The printed nDCG shows how SPLADE reshaping affects ranking quality. Next, we'll slot a late interaction re-ranker into the same pattern. This snippet slots a ColBERT re-ranker into a PyTerrier pipeline using PyTerrier ColBERT. The ColBERT factory loads a ColBERT v2 checkpoint on CPU, and TextScorer computes late interaction scores between query and document token embeddings. The pipeline takes the BM25 top 3, enriches them with text via getText, and lets ColBERT generate new scores for reordering. We then evaluate with experiment and pull nDCG cut 3. Using CPU is slower but avoids GPU assumptions. Increasing the BM25 candidate pool raises recall and can lift nDCG at increased time. The printed nDCG reveals ColBERT's re-ranking impact versus pure lexical scoring. Finally, we will run all 3 systems side by side and pick a winner. This example runs a side-by-side benchmark in PyTerrier across BM25, SPLADE, and ColBERT. The list runs collects the 3 pipelines and names labels them for the summary. Experiment executes each system on the shared queries and queries, computes nDCG cut 3, and returns a tidy results table. We convert the nDCG column to floats, find the index of the maximum with IDX max, and fetch both the winning system name and score. If you increase the metric cutoff or expand candidate pools in earlier steps, the ranking of winners may change. The printed winner and score give a concise, reproducible decision point. This toy benchmark maps directly to production choices. Replace the tiny index with your full corpus. Increase BM25 candidates before re-ranking, and swap CPU for GPU as needed. The same experiment call scales to larger CRELs and many more queries with identical evaluation logic. Recap what it is: a reproducible BEIR-style comparison in PyTerrier that evaluates BM25, SPLADE, and ColBERT on the same queries and queries. When to use it: when you need a fair head-to-head ranking decision across multiple retrieval approaches. One caveat: re-rankers are sensitive to the candidate pool size, so candidate recall limits can hide their true value. Next step: tune BM25 K1 and B while holding re-ranker candidate pools fixed to see how lexical tuning shifts the re-ranker gains. If practical, hands-on IR helps you. Subscribe and watch the rest of the IR videos.